All right, you guys, we are on the next lesson. So this is similarity and similarity transformations. So just when you thought you were getting away from transformations, they are back. And that's going to happen quite often, you guys. We're going to talk about something in here and you think it's going to go away and it'll come back. And that's just because geometry is something that builds on itself. It's not like algebra where you get a topic, you go over it, you think you've got it. You get a new topic, you go over it, think you got it. It doesn't really build on itself. Geometry is very much a building block to the next step. All right, so I'm on slide number 6, and it looks like we have some sort of activity. So I'm going to click on similarity transformations to see what we got. All right, so I got a bunch of figures here. All right, let's see what's going on. All right, in this activity, you will use GeoGebra to explore using similarity transformations to map one polygon to another. Okay, so determine the sequence of rigid motions and dilations. All right. So rigid motions are your big three: your rotation, reflection, translation. Dilation is not a rigid motion. That's why they have these two separate. That map the pre-image ABCDE to each of its images. If no sequence of rigid motions and dilations map ABCDE to the image, state that in the table. Remember to describe each transformation completely. For example, you must specify a line of reflection for each reflection in the center of dilation for the dilation. Perform the transformations in GeoGebra to check. Okay. All right, so let's see what I got here. So first thing I got to do is FGHIJ map onto ABCDE. All right, so where is it? Okay, so it looks like, and here's my ABCDE. I'm going to map it onto this gray one. Correct? Yeah, okay. So I got to make this pink one sit exactly on top of this gray one, which is its image, if it will. All right, so first thing, I see the pink is too big. I need to shrink it. So I'm looking at this. This is a 2 in distance because it goes from 0 to 2. This one is a 6 to a 7. So this little black one right here is half the size of the pink one. So I need to shrink this pink one so it's half the size. All right, that's the first thing I'm going to do is I'm going to do an N of 0.5. And about the origin. All right, so I need a dot on the origin to know what to dilate to. All right, so I'm going to shrink the pink one to half the size. All right, so come over here to dilate from point. That's why I had the point there. And you're going to click on the figure, and it should highlight the whole thing, and then click on the dot at the origin you made. And I want the scale factor to be half the size in order to shrink it, so I'm going to put 0.5. I'm going to click OK. All right, so now my pink one is half the size that it was, and you can see it definitely matches up to the same size as that little black one over there. All right, now it looks like I'm going to have to rotate this sucker because I see a little flat area up top, but the flat area on the black one is at the bottom. Well, that's going to be a rotation of 180 degrees because I need to rotate a full half turn so the flat on top is down, the flat on the bottom. So I'm going to have to do a rotation 180 degrees. Now, it doesn't matter if it's clockwise or counterclockwise in a 180 because if you turn to the right or you turn to the left 180 degrees, it's going to be the exact same. So I'm going to do a 180 degree rotation. I'm going to use that same point that I have. So rotate around point, click on this new pink figure, and it should highlight the whole thing. Click at the dot at the origin. I'm going to change this to 180 degrees. Now, again, it doesn't matter if it's counterclockwise or clockwise because on a 180, it's going to sit in the same position no matter which way you go. So I'm going to click OK. All right, so now I got it sitting in the same kind of orientation, my little flat areas at the bottom, the little flat areas at the bottom. So now I just need to move this sucker. I need to translate it over. I just got to figure out how much to translate it. All right, so remember, a full move is 2. So I need this little dot right here, this little B, to be sitting on the G. So I need to move it over 1, 2, 3, 4, 5, 6 to the right, and then up 1, 2, 3, 4. So let me count that one more time. 1, 2, 3, 4, 5, 6. So it's going to be here, up 1, 2, 3, 4. So translate right 6, up 4. And then I'll be sitting exactly on my black. All right, let's see if I can get this done. So right 6, up 4. So I need to go to a translate by vector. Click on this object, because that's the one I want to move, and it should highlight. So I need to draw a vector right 6, up 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah, I'll just do it right here. So I'm going to put a dot. 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4. Oh, I miscounted. What did I do? So it looks like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Looks like I need to move this over another 1. So I'm going to come to move it over another 1, and then down a 1. All right, so it looks like I went over 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. So I just miscalculated or miscounted. So 1, 2, 3, 4, 5, 6, right 7, up 1, 2, 3, right 7, up 3. So I'll change this to a right 7, and I'll change this to an up 3. All right. All right, so sorry about that, you guys. Hey, silly mistake on my part, but it's a good teaching moment. Shows you that, sometimes you may look at it wrong and you got to come back and fix it. All right, so there is my pre-image ABCDE laying on top of its image FGHIJ. So this one definitely is a sequence. All right, next up is KLMNP. All right, so I'm going to come back to my original, get rid of all of this stuff. All right, so KMLNP. Oh, okay, so this really big blue one. I got to get the pink one to be the blue one. Well, first off, I see that it needs to be a lot bigger. This is 2 over, but K to L looks like it's from 4 to 8, so it's 1, 2, 3, 4 over. So I need to get my pink one to be twice as big to hit the blue one. All right, so I need a point of dilation, so I'm going to put it back at the origin just because it's easier to do. All right, so I'm definitely going to have to dilate this sucker to twice the size, so n equals 2 about origin. Remember, 2 means twice the size. So I'm going to come over here, I'm going to click on dilate from point, click on this pink figure, which is going to highlight the whole figure and the point of dilation. I need a scale factor of 2 to be twice as big. All right, so now, I'm going to have to move that so I can see it. So now my figure is twice as big. Well, it's already sitting in the nice orientation. I got my flat surface and my flat surface are both facing, the top. So it looks like now all I got to do is translate. I just got to slide the pink over and the pink down. So see if I can do this one right. So I'm looking at this B here, and it matches up to the L. So I need to move over from 4 to 5, 6, 7, 8. So I go right 4, and I got to go from 8 to 6 down, so down 2. So right 4, down 2. Translate. Right 4, down 2. Well, let's see if I counted this one correct. So I got to do a vector, translate by vector, and the pink figure is the one that I want to do. So I'm going to go a dot right 4, down 2, and hey, counted this one perfect. You see that pink figure now lies right on top of the blue. So blue and pink kind of make a little purple figure. So it looks like I did great on this one. All right, so no worry about that second one. All right, the third one. Looking at QRSTU. All right, so I'm going to rewind to my original figure. All right, so let's see. I'm trying to get this pink one to be on this red one. Okay. All right, so first off, let me see here. I know that it shrinks in size. Not half the size like the black one was, maybe 3/4 the size. It looks like it kind of hits, 3/4 of the way. That's what I'm guessing anyway. I'm guessing it's going to be 3/4 the size. Looks like the orientation is, oh, hang on a second. Yeah, the orientation is correct. Got a flat edge and a flat edge. Over here, the flat edge is up and down. The flat edge is up and down. The reason why I said hang on a second, something's not right. Look at this BC right here. It's a shift from a 4 to a 3. But this one, because that's a 1 shift, is not. It looks like it's a 1/4 shift. Guys, I don't think this is going to map. But let me be sure. So I need a point to dilate. So I'm going to dilate this. Well, I've always called it pink, but I guess this is more like pink. I'm going to dilate this pre-image to the 3/4 size, but something is not right here because what looks like a 3/4 size to QR, that's not a 3/4 size. That looks like it's been cut in half. All right, so let's do a dilation from point. Click on my pre-image and the point of dilation. All right, I want to make it to 3/4 the size, so it's 0.75, and click OK. Yeah, look at this. See that? That is way longer than this one right here. So even if I were to translate this over, you can see that this BC prime is longer than this RS. This is definitely not a mapping. So this one you can't do, not a mapping. All right, so I'm done with that one. Give me a second, somebody's at my door. All right, we're back. So let's see, now I gotta do VWXYZ. All right, so I'm gonna come back to my original figure here. All right, oops, that's one a little bit too much. All right, so what am I doing? Look, I gotta get this little pink figure to be on the green one. Okay, is that right? On the green, VWXYZ. All right, VWXYZ. Okay. All right. So first off, I do see it as smaller. Looks like this one goes over to be a 1. It has to go V has to go all the way over to halfway through here, but it doesn't. It looks like it's cut it. Looks like this might be a dilation of 0.75, and I'm definitely gonna have to rotate because that little flat up top is now on the bottom. All right, so it looks like I'm going to do N equals 0.75. Now I'm going to do that to make sure that's accurate. All right, so I need a point of dilation, so let me put my point back. Come over here and click on dilate, and that's my figure I got to dilate, and the point I got to do it. 0.75. Okay. Well, that looks about right. It's about, yeah, okay, and about 3/4 away, and about 3/4 away. That one looks about the same as that one. Okay, so it looks like it is 0.75. All right, now I got to rotate. All right, so I need that flat area to be at the bottom. So it looks to me like it's going to be a rotation of 180 degrees from top to bottom. So I'm going to say rotate 180. And again, on a rotation of 180, it doesn't matter if you go clockwise or counterclockwise. So rotate this figure, that point, 180. Okay. Oh, okay. Looks like I've got to do a reflection now. because this flat on the left needs to be on the right. So I've got to do a reflection. I'm going to do the reflection across the y-axis. So let's come back here. So reflection, y-axis. So I need to flip that pink figure over so that my flat area on the left is now on the right. So I'm going to come over to reflection around a line. I'm going to click on the figure I want to reflect, which is this pink one, and the line I want to reflect it across. All right, now my orientations are great. I got my flat surface at the bottom. I got this flat surface on the right. So the last thing I got to do is translate. I guess I got to figure out how much to translate. So it looks like right here I'm looking at 3 to 4, which is right 1 and down 1. So I am looking at translate, right 1, down 1. Let's see if I'm correct. All right, so I've got to move this figure right 1, down 1. So I got to do a translate by vector. This is the figure I'm moving. So I'm going to do a vector right 1, down 1.
Miss Eccles?
Yes, ma'am.
You're needing in a meeting 121.
All righty, I'll be right there.
Thank you.
All right, so it looks like I was right. Down 1, right 1. It's not exactly perfect because I'm not there, but it is right 1, down 1. All right, so I'm being called to a meeting, so I'm going to pause this. I'll come right back. All right, so I'm back from my meeting. Sorry about that. Let's see here. So where was I? Okay, so it looks like I'm good with this one. Oh, yeah, I just submitted. Okay, there you go. Question number 2. Based on your work with similarity transformations in question 1, what images are similar to the pre-image A, B, C, D, E? Which images are not similar? Well, let's see. Only, what was that one? The one, the Q, R, S, T, U is not similar. The rest of them were. All right. Question 3. Often there is more than one set of sequences that will take a pre-image to an image. Determine 1 or 2 other sequences to create F, G, H, I, J from A, B, C, D. Oh, okay. All right, so let me back up to the original. All right. And they said A, B, C, D to F. Okay, so the same one. So let's see what I did first because I don't remember. So the first thing I did is I dilated it, and then I rotated it, and then I translated it. Well, I'll tell you what, I'm going to keep translation last because if you translate first, then you got to do another translation later because you usually don't get to translate right the first time. So I'll tell you what, I'll just switch them and do a rotation first, then I'll do the dilation, and then I'll translate because I'm certainly not going to do more work. All right, so I'm going to rotate first. So I have to have a point of rotation. All right, and I'm going to come over here and rotate around point. So click on my pink figure and the figure there. I'm going to change this to 180. And I'll tell you what, I'll even do clockwise this time to show you that it doesn't matter, and it doesn't. This time I've got it over here, so now I need to do a dilation. And I believe it was a 0.5, correct? Yes, so now I'll do a dilation of 0.5. So I'm going to dilate point, click on my figure, and the point 0.5, click OK. And now I can translate. So it looks like I got to translate 1, 2, 3, 4, 5, 6, still 7, up 1, 2, 3. So translate right 7, up 3. So I'm going to do a translate by vector. Click on my figure. Let's see. Right 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3. Be about right. It's not going to let me do it right perfect right there. There we go. It's not going to let me do it perfect because that blue figure's in the way. But I can kind of drag and move it over. There we go. So now it's perfect right on there. That is a mapping. So I just did the switcheroo. I did a rotation first, 180 degrees. Then I did a dilation of 0.5. And then I did a translation. Right 7, up 3. So just said it did 1 or 2. I did 1. because this video is getting long already. All right, question 4. Got to do the distance formula, and I got to find the calculation of all of these. Oh my goodness. All right, so gosh, I am running out of time here. They only allow me 5-minute videos, y'all. It's going to be, I'm going to do a shortcut. All right, so I'm going to come over here to distance and length. And they want me to find AB, FG. So there's AB, FG. That was a 2 and a 5. So 2, 5. All right, BC and GH. Oh, I'm sorry. Looks like I hit something wrong here. Let me back up. So distance and length, A to B was 2. G to F was 1. I apologize, that was a 1. All right, let's do BC. So BC, that's a 1. GH is a 0.5. So that's a 1. That's a 0.5. It looks like I'm just showing that they're half the size. CD and HI. So CD was 2.24. And I can't see the H. Whoa! It's not what I wanted. I wanted to move. It is not going to be nice to me. I need to move that GH out of the way. Alright, so let's see. I need to find HI. So it's going to be half. So 2.24, 1.12. 2.24, 1.12. That's just half. DE and IJ. DE, IJ. So that's going to be a 2 and then a 1. Yep. 2, 1. EA. I'm done. I'll do all this. Come on, undo. EA. And then JF. So 5.66, 2.83. 5.66, 2.83. And for time, I'm not going to do the distance formula of all of those. Just know that they will all be the exact same. All right. Question 5. What's the ratio of the side lengths of a polygon F, G, H, I, J to the corresponding side lengths of polygon A, B, C, D, E? You guys, it's going to be 0.5 because that was the scale factor that I did. So it's going to be 0.5 because they're half the size. You can look at these right here. I'll go from 2 to 1. That's half the size. 1 from a half. That's half the size. 2.24. Divide that by 2 to get 1.12. That's half the size. So they're all going to be the ratio of 0.5 because everything is half the size. All right, so see, 1/2. All right, based on your work on questions 1 through 5, what is a similarity transformation? What is necessary to determine whether 2 or more shapes are similar? Explain in terms of rigid transformations, dilations, proportionality, and scale factors. Okay, so a series of rigid transformations and a dilation. So the ratio of the image and the pre-image is the scale factor. That's what they had us do. Alright, so dilation, rigid transformation, similarity, ratio, lengths, pre-image to scale factor, dilation. Alright, perfect. Alright, self-evaluation. There we go. Alright, so the takeaway from this, you guys, is the ratio is the scale factor. So a lot of this was not new for us, just kind of remembering how to do transformations, series of transformations and dilations. Alright, so that was slide 6, and I'll catch you on the next one, huh?